So I figure I can give this talk, and then since I'm really fairly versed in Mongo, I can continue on after that to just show you some stuff or answer any questions you have. Okay. My name is Nuri. I'm a Mongo master. Been inaugurated the inaugural recipient of the MongoDB Community Champion Award from MongoDB 2 years ago. I've been a Mongo master for 2 years, taking some of their exams and stuff, but mostly it's my experience of hands-on. I'm a developer at heart. I have my own consulting thing. We help people learn stuff. We help people implement projects and architect stuff. So that's what I do. And I started with Mongo in about 2011. And it's kind of worth figuring where we are. I mean, it's 2016, not too long ago, but 5 years is big in tech. The thing is that, well, gravity. I mean, we know relational databases. We know them for, what, 40 years now or something, right? And this is the world we know, and we know it fairly well. Sure, there's some corners to explore, but we understand that. And when something else comes along, we see other things, and we think, oh, well, you know, but the rules here apply there. But that's not necessarily true. And what I realized is that this kind of bias, this kind of gravity, keeps us pulling and asking potentially the right questions, but maybe not always. Maybe we're not always asking the right questions. Maybe we're assuming that the rules of here apply there. And we're not enjoying the whole benefit of the big world when we're making those assumptions. So I figured, since I realized this gravity keep pulling us back, I figured, well, why not tell a story? I'll tell you the story because I've lived through it several times. If you work in corporate or you work with a team of people who are used to just developing and doing database and then doing some code and doing all of that kind of system building, then either if you adopt Mongo, you will live through the story, or you have seen this before. So I figured I'd share this with you. So the big boss walks into the room and says, "Good news, everyone," right? "We had a meeting, our company's doing awesome, and we've decided at the board that we are going to sponsor a makerspace." You know, makerspace, that place where you have people who are techies or, you know, creators of stuff, people who don't like going to the store, people who need some tools, put together some bale wire and some LEDs and make awesome stuff. And we're going to support that because that's a growing trend. So, you know, it's going to be this shared workspace. We're going to hire some, you know, rent out some space, and we're going to have tools and instruments strewn around and some workbenches and stuff like that. And then we're going to do some membership. Some people are going to come and participate, and, you know, they're going to have a sense of community, and they're going to work there and enjoy and create awesome stuff. It's going to be great for our PR. It's going to be great for them, and it's just something, you know, our company can branch into. Fair enough. And the marketing's like, "Oh yes, it's going to be awesome. We're going to make $1 billion. And I've already bought some advertising on TV for 6 weeks from now, so no pressure. I'm sure you can do it." And the PM's like, "Yeah, well, you know, yeah, let's think about that. What are we going to do here?" Out of nowhere comes table guy. "I know. We can do it. We'll put the stuff in tables and constraints and normalization. We know how to do it. Right? Everything we need, the whole IT system, we'll just figure it out. Let's see, what do we have to do?" Well, first, we have these people, right? We have makers, and we need to track them. So, you know, we have a person table. And every person has an ID, and they have a name, and last name, first name. Okay, great, awesome. We know how to do that. Oh, makers are people, yes. Oh, yes, yes. Not every person is a maker. Oh, so we're going to have a maker table to contain the extra stuff that makes a person a maker, maybe their membership status and stuff like that. We're not going to store it there because this is generic people, right? We have our mailing list of everybody from our company, but not everyone is a maker. We're going to have to model it somehow, right? And then, oh, tools, right? In the makerspace we have tools, so we'll have a tool table. every instance of a tool, right? A hammer has an ID, right? We can have multiple hammers, so a tool has kind of a tool type, right? And we'll tie it in. So we can track the individual things, right? This drill, that drill, two separate drills, and we track their type and we can do things. Drills are kind of funny. What about other stuff? What about a lathe? Or, I don't know, a washing station or a CNC or other machinery, fixed machinery? What about those? Well, okay, so some of those things are not exactly tools. Maybe they're assets in a more general term. And a tool is an asset, but not every asset is a tool. So we gotta have our fixed assets, like our tables, our shelving, other things. And then, tied in through what we already described. So, fair enough, we could capture that data. And then some of these tools are kind of gnarly, you can get injured, and maybe you need some instruction on how to use those tools, so we're gonna have certification. Before you use it, we're gonna make sure you have certification. So we'll need a person tied to a maker certification. Actually, that's a maker, right? But we can tie certifications directly to the parent ID or through the maker. And a maker certification will track a specific certification, right? So I have a certification for an oscilloscope. Well, that's a certification, and then I need to tie that one to this guy and to the other guy, so I'll do this intermediate thing. And maybe a certification is related to the tool type, just so we don't lose track, so it's a real thing, right? Lest we create a certification not tied to a tool. I don't know how we're gonna do that. Some risks already, right? We can award you a CPR certificate, but it's not related to any tool. Nullable relationship, then how do we verify? I don't know. Anyway, but this will do the job, right? So here we are, 5 minutes in. Is it 5 minutes in? I think even less, right? We haven't even started. Gravity already hit. This guy's happy. We know how to do it. We have all the data. And we can relate all these tables, store it there, and there you go, boom, mic drop, I'm done, right? Now just the application developer will have to go and interact with this in some shape or form, if we let him. If not, we'll create stored procedures for them to talk to us through welder's gloves. But, this can be done. But this is gravity, right? This is how we're used to doing things. So let's try to think about it again. From the top, the boss came in, they told us what they want. We have to develop a system to track this makerspace. Let's take another look at it. What is it we're really trying to do? Well, we have these maker people, right? And they get certifications. And then we have tools, and they need to borrow and return a tool. And we need to be able to do accounting, right? See what tools are out for lunch and what are going to be checked back and who's delinquent and should we buy more hammers because we have so many hammer users. Hammer time. So the first thing about thinking more document-oriented is not to think about how we could store things, but think about what are the key interactions with the system. I showed you the slide before. We had 3 interactions, right? Maker and certification, check in and out tools, and report the usage, right? That's what we need to do. That's what we need to achieve. So whatever we do, the system needs to achieve that, right? And that drives our thinking of what we need to do. So let's tackle that. We can do that, right? We can use gravity to our advantage and just say, stay here on Earth, this is what it is. But doing this proposes that all of this data just is, and then we have to take a narrow view of it. Let's say those 3 relationships model of certain things, person certification. That relationship, tool to tool type, typifies a tool and has tool instances. Another one tracks the transactions, right? But those are perspectives on top of all of those constructs. And this supports seemingly endless perspectives, but not that efficiently. And when it comes to efficiency or comes to time to market, we then have to write gnarly joins and write all kinds of long language in order to allow us to take that perspective. And if they collide, we even need to write more code to do that. So let's just say this can do things, but it is not necessary that that's the best way to do things. For instance, why is my data scattered across table? Like, why does my certification live outside of me? It's my certification. What if all certifications in the certification table decided to rebel one day? What if they cavorted together and intermingled? I mean, they don't belong together. Their affinity is just structural. Yeah, there's a certificate ID and a name, so because of the structure, they live together. But they really don't belong there. The ownership of the data is elsewhere. And do all the objects have to be flat? What if I had a C# object? Yes, I program in C#. What if I had a C# object that had an array, a dictionary, a hash table, a set, a nested array of objects that are all my addresses, or things like that? Do I have to scatter them around? Doesn't always make sense to me. And can we iterate rapidly? If I just wanted to change something, add a property, remove a property, change structure, do I need to then go and tell the database, hey, I am going to tell you a different thing from now on. Forget the past structure, I have a new structure, right? Where if I had a system that didn't require me to do this, I could iterate faster because my software would define those constructs. So let's start with person. There's a maker, the mother of all makers, Miss Stewart, out of jail now. I'm going too far. So there's a person, they have an ID, and they have a name. And they have a last name, first name, sure, Kraft. Okay, we're good. So that's a person, that's generic. There's nothing makerish about it. But I can inherit or enhance that and decorate this with maker-ish kind of attributes, like their maker status, or their maker ID, or their key card PID number, or something, if I needed to. In MongoDB, we can do this without telling the database ahead of time, hey, we're going to give you another property, please be prepared. So it's really fast for us to do things. And MongoDB can hold some documents that have this extra property and some that don't. So if I have a master collection, yes, it's structural, that contained all of the people, yes, those are people, some of them are makers, have this extra thing, Mongo's just happy. There's no problem with that. So the data that tells me, oh, this person is a maker is here. I don't have to go anywhere else in the world to find that out. Okay, I could do a nullable column maybe, kind of cheat my way into that. Most of those will be null, but some will not. Yeah, I can do that in relational, but this is kind of clean, isn't it? Now, what about certification? I have more than one certification, right? I can use a hammer, I can also use a drill, and I took that course on oscilloscopes. I can even pronounce it. So I can store my certifications with the same object. It's about me. It's my data. It's not anywhere else. It's right in here. And MongoDB supports me with being able to store this with surgical updates. That's what I call them. You can update a specific document, update the person named Martha. I'll probably use the ID, not the name Martha, because I can have several. And I'll find the one that does not have the certification on a CNC. That's one of those boring machines, right? Boring, B-O-R, not. So So I'll find Martha. If she doesn't have a certification on CNC, I'm going to add to the certified array, I'm going to push on a CNC certification because she earned it. So there's this surgical update I can apply. I can take a bunch of IDs, I can take any criteria of which documents to decorate, and then add the decoration. I don't have to read it out, scribble on it, put it back in. I don't have to write Nuri joins. I just say, hey, put it if it's not there already. So that's kind of nice. That supports me in adding certificates as I see it fit. So every once in a while, I'll put them in there. Now compare this to what would happen in table land. Add a person, okay? Maker, person. I'll cut you slack on that one. Then I had a maker certification, and certification, I would store the fact that the certification belongs to a person outside the person and outside the certification. This exists just as structural craft, right? I never want to see this data. I want to always say, oh, get me my certification, go through Bob, then come back to the certification through a third party, through welder's gloves, in order to reach that information. So in MongoDB, the thinking about modeling this is that data that works together lives together. And really, me and my certifications, I own those certifications. They are mine, and we work together, right? Whenever I participate in this makerspace, what happens is that you'll look me up and you have my certifications right away. Can I check this too loud? Oh, let's pull Bob up. Okay, here it is. Okay. Yes, but, you do this, you lose your referential integrities, right? How can we assure that you're putting in the right stuff? What happens if ever we change CNC to computerized something control system, or whatever those acronyms mean, right? Then we'll have to change it multiple places because you copied data around. How do we assure all of that? So there's this idea that, you know, data should drive our application, right? That this referential integrity helps us. And we have a lookup and we say only those certifications can go into this person or into this person's certification. And there's danger in that, actually. The danger is that one day the logic in my application looks something like this. If the tool type is not hand tool, then, whoa, you need certification, right? Anything with a plug, I'll assume you require certification. This is logic that somebody wrote at the time that they knew about the universe of data that existed, all of the tool types that existed at the time, right? So a knife or a hammer or a thing that is a hand tool, sure, go kill yourself, we don't care. A power tool, a stationary thing, oh, you need a piece of paper for that one. Okay, so this implemented that. But tomorrow, what's going to happen? I'm going to have another tool type, instrument. And the instrument may or may not require certification. But this made an assumption only knowing these three things. So the meaning of this logic now changed. You see that? Oh, there, I fixed it. I know how to do that. The fix for the data-driven problem is more data-driven. See, what we can do is we can say on each tool type whether or not it requires certification. Then my logic will be just if tool requires certification equal true, then yes, otherwise no, which makes sense. Except for one thing. We write programs that have 50,000 lines of code. We write programs that have 150 lines of code, 1,000, or 1,000,000 lines of code. How many extra columns will I need so that every branching decision based on static lookup types will need to be data-driven? I'll need a rule system just to run my rule system. So this is possible, right? It's possible to use those relationships to constrain what can go in, However, there are problems with it. It doesn't inherently make it safe. Certainly if I deployed more data rows and the logic wasn't written against them, we don't have a great chance of validating. Furthermore, any programmer in any higher, not higher level language, but definitely statically typed languages would have taken those types, hand, power, stationary, and created an enum, a discriminated union, in order to program against it so that they have symbolic names. So then if I added another data type, the program will just blow up because it can't translate it into this type. So it's possible, right? It's not that it's impossible, and it's not even that it's completely insane. It just has ramifications. If we make systems that look like this and like that and have to work together, we have to coordinate the deployments. We have to put it out in production together. We have to figure out either to take the system down and then upgrade both and test it and then bring it back up, or we have to do some very, very careful programming, pre-deploying the software, then performing a rolling update and doing a lot of machination to support this. With MongoDB, not so much. We don't have this, oh, tell the storage that I'm going to add a column. All we have to do in MongoDB is insert a document however we want to see it with whatever properties we want. We want to update a document, say the document with the ID 123, and add a field that says is certifiable true. Just add it in code. And MongoDB will take it and treat it as a first-class citizen, a field that's completely indexable, completely addressable. It's not an opaque blob. It knows about those fields in the document. So the conclusion here is really more about static data. Lookup data that we use to create a referential integrity for or a relational constraint on is data that typically you could embed fairly safely. I have 180 country codes. Tomorrow I have 181. Okay, so what? So I can embed the country code US everywhere. Do I need the ID of that country should the US decide to change its two-letter code? Happened. Actually, in the last 10 years, we had some changes in major country codes in Europe. But, yeah, go update it where you need to, and you're done, right? It doesn't change every second, every hour, every day. It's relatively static. So it's okay to embed this kind of data. Okay, so table guy is looking at it and saying, okay, embed data, I get it. We did the maker certification thing. How about the tool borrow and return? Right? We could, for any tool, right, the scope, I'm too lazy to write oscilloscope, we'll have borrow array, and we'll have in there, we'll just add items, right? We saw that kind of push onto an array kind of structure. We can add things in there. Not so fast. The issue about embedding is that you want to think about the lifetime of the data, the ownership of the data, the scope, the rate of change of the embedded data versus the outside data. So let's think about a few criteria. Who owns these borrows and returns? Is it the tool that owns them? The person that owns them? The makerspace that owns them? Right? Do they have an existence of their own? Are they their own first-class entity? Or are they really owned by something bigger than them? That's one consideration. The second is, do they work together? Am I likely to see them always retrieved as a unit and updated as a unit? And there I would see that probably with the tools, they kind of work together hand in hand, but I'm not sure all of them work together. Maybe the last one is, but not all of them. Another axis is the bound growth. Over the lifetime of a very popular tool, I can have thousands of transactions. I'm not in a makerspace, I'm in a hospital. Every time I take the defibrillator, I have to register it, right? In, out, multiple times a day. So this transaction, these transactions will grow the document basically ad infinitum. So MongoDB constrains you. It says, hey, you can't have more than 16 megabytes worth of document. Nuri says, well, if you have 1 megabyte, come talk to me. I'm not sure so much data should really live together. Does this data really need to be together? It sounds a little dubious to me. So unbound growth, another reason not to put it there, you know, Ashton Kutcher, too many tweets. We can't just have one document for all their tweets. Doesn't make sense. Because it has a different lifetime. So maybe each tweet has its own lifetime, right? So in our case, we see that we could make a semi-case for some of these considerations, but certainly not for all of them, right? And in this case, I think that a ledger approach would be better. Kind of like a transaction log, right? Each time you borrow, you say, sign in the bottom line, I borrowed. And each time you return, we add a thing to that transaction ledger, right? That's how financial system works. I think it could work for us too. And if we have this ledger, each of those entities is a first-class entity, and I can query across all borrows and returns with ease. So we have the maker get certified, and we have borrows and returns logged. How are we going to report the usage? For that, the best trick is the aggregation framework. The aggregation framework in Mongo is its join mechanism. There are no joins, sorry. It's reporting mechanism. The reporting mechanism lets you go across a single collection and apply a pipeline of operations cobbled together to create your results. We can do filtering across a collection. Okay, find me only the ones where the checkout action was checking out, not in. Right? And only find me the ones within the date of the last month or whatever. Then group them around the tool name. So I'm going to have the tool name as my group by pivot. And then across the tool name, I want you to count $sum of 1. This is a nice way of saying count. Sum of 1 just adds 1 for each instance it finds of this tool name. So this produces a report that shows me the hammer had 2 checkout actions within this period, and the torch had 1. Flashlight for those who are not familiar. So that's aggregation framework. Similarly, I can go deep on a field and I can take a member's first name or a member's last name. So I have dot notation. I can reach into all of these fields and create like who's the most frequent borrower of tools this month. And I can also produce a bigger report which says, well, not only do I want to know who borrowed, I want to know what's still outstanding. So I want to create a report where the maker name, I have it, and what they have, and when, since when do they have it, and even add the number of days so that I can have kind of an aging report on my tool loan program. So for that, you can build a bigger aggregation pipeline. The important thing here is not the syntax. The important thing is that the aggregation framework lets me build pipelines that are as elaborate as I need them. Here I cobble together, first I do the latest to first. I pivot around the tool and I grab the action and the date and the maker name, the first ones on around each tool. And then I only take the checkout transactions, and since it's sorted by the descending, I get the latest one. And then I can project out, meaning reshape the values that came out to get the maker's name, what they have, when they checked out. This at refers to the first date, which is the last date since I sorted descending. And I even do some math computation to show how many days have passed since today, right? Syntax, it's available. It's different than SQL, but it's just syntax. So here, the main point is that when we're thinking of modeling those interactions, what we're trying to do is pitch into the strength of the database engine. Relational databases are good at keeping relationships. Mongo is good at storing and manipulating data, and has this query retrieval language, this aggregation framework that lets us do the fancy work. So let the server do that for you. I see that mostly with Node.js people, where they're not quite aware or doing things and they slurp up data into memory and do things in memory in order to do aggregations and all kinds of stuff. So really you want to look at the aggregation framework. You don't want to do this in memory and slurp up all the data over the wire. You want to let the engine do the work for you. So another option, and I kind of alluded to it before, is I have one big transaction log, right? Has anybody tried to create a gap report where you had things that should have been in pairs, like checkout, check-in, checkout, check-in, but you wanted to see the distance between the last checkout and the checkout before it? That's inherently non-relational. You have to kind of walk the path. You kind of have to do iterative programming to achieve that. And in Mongo, it doesn't become much easier. You can do things with the aggregation, but it still could be gnarly. But there's an idea of supporting this tool log, this ledger that we had, just as we did, but with one extra I/O transaction per borrow, we can also put some of them into the tool. Wait a minute, Nuri, you said I don't want it in the tool because it will grow and grow and grow. Well, there's special syntax that allows you to put items into the tool but only keep the last n. This is this slice business. It says keep the last 3 only. So the idea here is each time I borrow a tool, I'll add it to the tool itself, as well as put it in the main log. Write it twice. Fine. What I get by that is, first of all, it's really easy to tell if a tool has been checked out, right? I can always find the latest transaction on it and say, are you in or out? That's possible, but I have to walk to 2 places. If I'm already loading the tool, I can tell just by looking at it what the last transaction is. To keep it from unbound growth, I do the slice business, so I get the best of both worlds. I can transactionally say I can check out this tool by saying modify it and add one if it's not already checked out. And I get my all of history that's very, very scalable. This collection can grow huge, and I can shard it linearly. I can split the data into different chunks and scale out my farm if I need to. So this is a kind of a hybrid approach that gets you the best of both worlds with the cost of an extra write each time you want to do a transaction in here. Yeah? I'd probably write this first and then write that. That way, if it ever failed, I can always walk up to these guys and rehydrate. That's just me. So, taking a step back, let's look at Table Guy's idea. We had this notion of a person who's a maker, who has a status and some certification attached to the certification and all of that stuff, right? And we have these assets, you know, those tools, and their type and stuff stored, right? And we have that transaction log. These swim lines are really not that different than what we've seen on Earth and out there with Mongo, right? We kind of replaced this with our document modeling, actually. Not too far. And this is kind of the perspective thing, right? It's not that the table was all wrong. We had these notions already. It's not that unfamiliar, but we took a very specific perspective on it, the usage perspective, in order to find the efficiencies in what we want to model and how to model it. So we ended up with those entities. Yes?
This is a totally, I'm not a developer question, but that mean that MongoDB performs faster? Typically faster? Is that a stupid question?
It's not a stupid question. It's a good question to ask, and it's a tough question to answer.
Okay.
Because faster is not always the goal.
Okay.
Because faster has to do with your hardware. Because faster has to do with your transaction access. I cannot guarantee you that certain thing will run faster or slower in system A or system B.
Right.
And there are certainly ways to make relational databases really, really fast, and there are certain modelings and queries that will perform better, or seem to perform better, on traditional single table queries. Once joins are involved, typically a document query, which retrieves the whole thing one shot, is cheaper and faster than joining 3 tables to get the data, just because of locking and stuff like that.
But on that question has been my big question in my head so far. I mean, I'm seeing this, you take the XML analogy, that concept, and you apply it to a database, and then you have the database management system over it, making it easier to navigate that. But if you're going across multiple, in this case, if you're doing like a list, how is this faster if it's having to go into each document, or is it relying on the indexing? Is it pulling it out of the document?
Let's keep that question.
Okay.
I'm about almost to the end here. And then let's get back to those questions and maybe look at some examples and talk more specifically about specific concerns. So we have these documents. We basically took a perspective on our whole data need and put it together according to our usage. And we discovered that we're not too far from where we were before in our thinking. We just didn't draw the swim lines necessarily because everything was potentially related to anything, right? But now that we did it, we gained the efficiency of knowing that it's fitting to our problem. It's not something generic that then I build an application on top to make it my perspective. It is that perspective from the beginning. So it does help, and it will help performance. We took the interactions and we drove this perspective. We took data that was previously scattered and put it together for the benefit of having it live together where it works together. We embedded immutable data. We're not terribly afraid that, if my name was Bob Smith and tomorrow I want to be Bob Johnson, well, so I wrote 1,000 blog posts. So I'd issue an update and say, change wherever the author ID is 123, last name is now Johnson. Bada bada, fine. Is that what scares us into making it relational for the sake of putting it in one place? It shouldn't. And we want to let the engine, we want to know enough about it, about the query syntax and surgical updates and indexing. Doing that alone, that knowledge, digging deep into it and not just using the surface tooling, is actually what I think might help the most. Once you know how the engine works, once you know what's efficient, how to store things, what operation you can do, your modeling thinking starts changing into and pitching into the efficiency of the engine. The elephant in the room is really that the relationship between table guy, which could be me, and the developers has changed. Because what we haven't talked about is that the responsibility for maintaining data integrity, the responsibility for maintaining performance in the data layer is not solely on the shoulders of the DBA. In fact, they have very few knobs to turn. They have operational knobs to turn, but they cannot tell me how the schema would be ahead of time. With Mongo 3.2, now they have this notion of a validator. It's not exactly a schema. So you can attach to a collection, you can attach a set of rules and say, hey, here's my suggested schema. And developers may say, okay, I want this on, so that if ever I try to write a wrong document, it will stop me from doing it. It's possible, but it doesn't enforce it, meaning that somebody with sufficient permissions can always just ignore that altogether and say, write it, I know what I want to write. So we don't have that schema enforcement. So in this world, what we gotta be thinking about is that stuff we discussed about efficiency and all of that. As a team, we have to come to a new arrangement on how we conduct ourselves and build software and maintain quality and maintain the quality of the data long term. It's not what it was before. That is the most different thing between the earthbound and the spacebound objects. This is not the same. And it's worth talking about. It's worth discussing with your boss, with your peers, with your, with anybody who works for you. This is what makes teams work, is this understanding that came with all of this experience of 40 years. We don't want to throw it out. That was good thinking about data. We want to figure out how do we as a team develop systems and maintain that data coherency, but delivering fast, but being able to scale out the residue, but being able to iterate and deliver features driven by the requirements. So that's all for this talk. Thank you very much.